Hey, science enthusiasts, welcome back to another exciting episode where we dive into the wonders of nature and the science behind them. Have you ever wondered why lightning both lights up the sky and makes a loud noise? It's a fascinating question that combines elements of physics, meteorology, and even a bit of chemistry. Witnessing a lightning storm can be surprising, even a bit scary, but it's actually an incredible natural phenomenon that we can understand through science. The interplay of light and sound during a storm is a perfect example of nature's raw power and beauty. Let's break it down step by step. By understanding the basics, we can appreciate the complexity and marvel at the simplicity of how it all comes together. First, let's talk electric charge and atmospheric detuning. These are the fundamental principles that set the stage for a lightning storm. During a storm, electric charges build up between the clouds and the ground. This build-up is due to the movement of particles within the storm clouds, which creates a separation of positive and negative charges. Imagine it like a giant battery in the sky. The clouds act as one terminal and the ground acts as the other. The difference in charge creates a potential for a powerful discharge. When these charges accumulate to a critical point, detuning happens, creating a pathway for electricity through the atmosphere. This pathway is what we see as a lightning bolt. Now, on to the specifics of lightning. When this electric current finally discharges, it superheats the air to thousands of degrees Celsius in an instant. This rapid heating is what makes lightning so bright and powerful. This intense heat creates plasma, a state of matter where electrons are stripped from atoms. Plasma is incredibly hot and emits a bright light, which is why lightning appears so luminous. The atmosphere around this plasma glows brightly, forming the lightning bolt that we see lighting up the sky. It's a brief but spectacular display of nature's power, but what about the sound of thunder? This is another fascinating aspect of lightning that adds to the drama of a storm. When the temperature increases so suddenly, the air around the lightning bolt expands rapidly, creating shock waves. These shock waves are essentially ripples in the air caused by the sudden expansion. These shock waves travel through the air at super fast speeds and are what we hear as the loud bang of thunder. The sound can vary from a sharp crack to a long rolling rumble, depending on the distance and the nature of the lightning strike. You might have noticed that you always see the lightning before you hear the thunder. This is a common observation and has a simple explanation rooted in the physics of light and sound. This is because light and sound travel at very different speeds. Light travels almost instantaneously to our eyes, while sound takes a bit longer to reach our ears. Light zips through the air at about 300,000 kilometers per second, while sound lags behind at just 343 meters per second. This difference in speed is why we see the flash before we hear the boom. That's why the light arrives first and the sound follows a bit later. The delay can also help us estimate the distance of the storm. The longer the gap, the farther away the lightning. To recap, the light and sound of lightning are created by complex interactions between electric charge, temperature, and air. These elements come together in a dramatic display that has fascinated humans for centuries. Hopefully this video has provided some interesting insights into this amazing natural phenomenon. Understanding the science behind it makes it even more awe-inspiring. If you enjoyed this video, don't forget to subscribe to our channel for more great content. We have plenty more fascinating topics to explore together. You can also leave a comment or send a question. I look forward to hearing from you. Thanks for watching and stay curious.